coded at NUS Games Development Club, GDG. Yeah, so far I created a custom level so far. And now the challenge is because as we open up to more people to do the level creation, it's come to my attention that the simple breakfast search that was done earlier was probably not enough because it kind of didn't scale up well. There was quite a bit of lag when we actually coded this out. Okay, so now I have one level. I get to collect three different, now it's called mandrake roots, three different mandrake roots while avoiding the hippos. The hippos will typically do a random walk, okay, until you are 3 squares away from the hippo, then the hippo will target you. Okay, if not, when you collect the mandrake root, one hippo will go to target the mandrake position. Okay, so only after you collect all three mandrake roots, okay, then all the hippos will come and chase you, and the flashlight wouldn't work. So if you shine a flashlight at the hippo will actually stop. So let's just try to play through to see what happens. So now all these are done using breadth search pathfinding for all the hippos. It can be a little slow. Okay, let me just put this side by side. Okay, maybe I'll just put it here. So the game is on the left, the scene view is on the right. So now everything is lit up because oh, that's a bit loud. That's a bit loud. Yeah. So as you can see, one of the hippos chasing me. Okay, so there's a torchlight that needs to be taken. Oh, that was really loud. Yeah. So now all the hippos will chase you. Okay, there seems to be some issue with the chasing also. So only one hippo is chasing right now. We want to make all the hippos chase. So this one needs to be done in the script itself. Actually, that could be done pretty easily. Okay, because is it not? Just make all of them chase me first. Oops. Okay, so that's some of the things that needs to be done. Okay, so maybe let's just do the script where we make all the hippos chase me, because I think this is a easier script to do than the A star script. So one thing that could be done is because whenever we collect a crystal, okay, in this case, the crystal actually means the mandrake root, okay, because we changed from a crystal to a mandrake root image halfway, but in the script everything is still called crystal. Mandrake root is supposedly more scary because it's like the Harry Potter when you pick up the mandrake root, it cries damn loudly. Yes, and that's a kind of effect. It's a horror game actually. You look at it like that, doesn't look very horror because we actually kind of turn on the lights, but just for testing purposes. But if you look at the okay, if you look at the inspector, you realize that um, if you turn off the lights, this is how the game should look like actually. So we play the game. The scene is on the left. Yeah, this right is just for debugging. So this is how the game should look like. Like you don't know where exactly it is. Then you sort of have to figure out where the hippos are. And the torchlight will be dimmer as you go. I still have one more mandrake root that I haven't found. So we are going to implement a pathfinding mechanism for rather an indicator to tell you where the nearest mandrake root is so that you won't be walking around aimlessly. Okay, better find the exit. Alright, that is. So that's roughly how the game works right now. But now, let me just turn this back on because we need to see. Now you kind of want to make the hippos, all of them chase you. Okay, when you collect the all three mandrake roots. So when you collect one mandrake root, you want to make the nearest hippo chase the player. Okay, so this all can be done over here. So there we go. There's this script over here. Find object type enemy movement, which basically finds the hippo. So if we collect the crystal, this is what would happen. Okay, and then if all the crystals are collected, then we will activate crazy for all of them. Okay, so let's just do the crazy one first. Okay, so for the crazy one, let me just show you the find objects of type. So instead of using find object of type, I'm using find objects of type, which will basically help to create multiple objects at the same time. So it help to find all the multiple objects of that certain class. So it will return an array. Okay, it will return an array of the type of all these object types, which you will then be able to find out their positions and you know basically use this information to do stuff. Okay, so we can do like find objects of type, and then we can call this a var enemies. Okay, and then for each enemy, I'm using a var here, but actually you can also use like enemy movement. This thing here would be enemy movement array, like that. Yeah, we could do it like that just to so we can do it for each. Okay, okay, so for each of this we can call enemy dot crazy. Yeah, so we could do something like this, and then uh, for the normal enemy over here, we can do a similar script. Okay, we can do a similar script in order to basically find out all the enemies. So I could do it here. I mean, yeah, I can pick it out from here. So we could have our enemies here. So we could do a for each loop here also. For each enemy movement, yeah. So over here is where we replace with enemy dot chase crystal, then the crystal's position. Yeah. So over here we could do a to do. Okay. So the to do is make the make only the nearest enemy attack the player. Go to Mandrake. Yeah. So we could do this. So actually I realized this if over here should come first. We can do this if over here. So I mean it doesn't really matter because when we call the script, crazy will override chase crystal in terms of the function because it's just changing the game state of the hippo. So we could do this. So this what we'll do is it will basically look through all the enemies. So we first find this one needs to come out. This one needs to be first. We first find all the enemies here, and then after that, based on whether the crystal is collected, whether is it like all the crystals, which means it's the last mandrake root, then the hippos all will go crazy. If not, then the hippos will all chase the player. So over here later we'll add in something here that helps to only make the nearest hippo go to the player. Okay, let's just try out to see whether it kind of works. This is the effort of a lot of people this game. Okay, let's see. So now if I collect a mandrake root, all should come to me. Okay, looks like it's working. All of the hippos should go to the mandrake root. And then all of the hippos should come here. Yeah, looks like it's working. And now all of the hippos should chase you, because all of them are in crazy mode right now. So if I shine a torchlight, they should still chase me. Oh, that's scary. Okay, so I guess that settles for multiple enemies. It's sort of working right now, and I'm quite happy with it. Now we just make only the nearest enemy go to the mandrake. So what we can do is here, float min this equals to, just make it a huge number. I'm not too sure what's the limit of float, but I'm just going to make it very huge. Okay, just call it -1 actually. Yeah. So we know the crystal is at this position. Okay, so what we can do is do this. So we can call this crystal X. And we crystal Y. Okay, then we can do because for the enemy itself, we can also use the enemy game object dot. Okay, so let me just describe what I mean by here. So we can do float enemy X equals to, you can just copy this whole thing literally. Enemy dot game object dot enemy Y equals to enemy dot game object dot Y. We could find a position of, so this enemy phase crystal can be put all the way at the back. So only the nearest enemy. Okay, so it's either only the nearest enemy, or actually I think, yeah, maybe the nearest enemy only. So only one hippo will be attracted by the sound, and the rest will still be patrolling. Okay. So what should we do here? So we already have the X and Y of the crystal over here. We have the X and Y of the enemy over here. Okay, so we can do Euclidean distance in order to find out what is the total distance. Okay, so the minimum distance is like this. So we need to calculate over here. We need to calculate distance of hippo to crystal. So the distance is given by this. Okay, float distance equals to crystal X minus enemy X squared. Okay, so we need to do like a squared. Okay, but in this case, what we can do is just to take this. There's probably a power function somewhere in C sharp, but I mean we can just do this. This is like a square, and then we just take a square root of this entire thing. But in this case, we don't need to take the square root, because if we compare the distance without the square root and we don't have the square root for all the distances, it's the same. So if let's say x squared is greater than y squared, we can conclude that x is greater than y. So we can leave it like this. So if min this is the same as -1, or okay, or min this smaller than this. Okay, So over here, instead of like maybe having enemy movement, enemy and enemies, we could do for int I equals 0, I. Okay, so array is length. So what we can do is I smaller than enemies dot length I plus plus. Okay, so this one will be given by enemies I dot, this one is enemies I, which means we take the game objects, we take the enemy movements function, the I location of the array, okay, which means the ith enemy, and we take the x and y coordinates here, x and y of the enemy, calculate the distance of the hippo to the crystal. Okay, if the min this is -1, means we haven't stored a minimum before. Okay, the min index will be stored as I, and the min distance will be equals to distance. Okay, so if the min distance is smaller than distance, that means you have stored a certain, no, actually it's the other way around. If the distance is smaller than the main distance, then we update the main distance as follows. Okay, so at the end, we could just do enemy's min index to chase the crystal. So the enemy at the minimum location will then chase the crystal at this position, x and y. And let's see whether there's any errors. I'll be surprised if there isn't any errors and the code can run. That means my coding has improved, or it's a simple thing to code. Oh, no errors. Wow, I'm impressed. Okay, so let's see. So when I take this mandrake, only one should chase me. Okay, let's see. Only one should chase the mandrake. Okay, very good. And now all of them should chase. Okay, looks like it's working. Let's try again. Let's try again. Only one should chase the mandrake for this. Very good. Yeah, it's working. Yeah. So you can see that only one. Okay, I triggered the hippo because I went too near to the hippo. Better run away. Oh yeah, that was good. That was good. Okay, now let's try to see whether this is playable without the lights. All right. Uh, this game is pretty hard, especially without a navigator function to tell you where the mandrakes are. I don't even know where I am now. Oh, there we are. Where's the last mandrake? Oh, whoa, whoa, that was scary. Ah, there it is. Okay, looks like the game is good to go. Yeah, so that was the player interaction script. Let's change this part here. Okay, so now let's do the A star search. Okay, so next up will be the A star search. And to do the A star search will be over here at the enemy movement. So enemy movement, previously we have created this entire class. So like with all the different states over here. Okay, so we just move straight to the function that gives us the reference search. So this was the reference search initially. You take the reference search of your start position and the end position. And then it will return a direction, which is basically the direction of the direction array will basically tell you what's the direction of the first move to take. So in order to do a star search, Instead of popping the first node in the queue here, we need to store the so we need to pop the node which actually has the so instead of popping this node in the queue, we basically just want to pop the so we need to pop the node with the highest priority. So we need some form of a high priority queue here. So when we store the node in here, when storing the node, store the current distance to node plus a heuristic distance to end goal. So in this case, the heuristic distance, we just put end goal here. The heuristic distance that we will use is a Manhattan distance, which is basically the x1 minus x2 plus y1 minus y2, absolute value of this. So we need to store this inside the priority queue so that um, we can extract it out when we do the DQ up here. Okay, so where do we get the numbers for the uh, where do we get the numbers for the total distance of the node so far? Mm, Currently, I don't think we have anything right now. We didn't really store the value of uh, like how long has it been since the starting node, but we can start storing. Yeah, so there's no distance here. There's only is visited direction. So yeah, we could just store so int total distance to current node. Yeah, so let's just create a new, we can just copy this. So in our distance, okay, to the current node, we will need to, okay, so enqueue start node. Okay, so over here, start node, sorry, this. So the start node is a number, I believe. So the start node is a position. So the distance of start node will be equals to 0. Okay. And then what we'll do is when we encode this in here, um, okay, because the distance are always uniform 1, so we don't really have to store like distance to current node plus the age. We don't need to check whether is it smaller than the distance to the other node, because by doing um, by doing this a star search on a grid with distance only 1 per between any two nodes, two accessible nodes, we don't really need to do that check for the distance. We can just simply update the distance to the node whenever we push it in the queue here. So can do like this: distance up node equals to distance node plus 1. So we could do the same here for this one here: up node, right node, down node. It'll be good if we could like do the up node, down node, left node, right node into like a list, which will like go out to an array. Then we can just loop all these four together. But because of this special condition over here, this direction here, actually we could, yeah, actually we could do this entire thing into a for loop. We could subsume all these four if we store the up, down, left, right into an array of four, size 4 of integers. We can actually store this all four into one. It's just that this condition here will probably need to check current x smaller than y max, current x smaller than x max, current y greater than y min, current x greater than x min. We need to check these four conditions for all the up, down, left, right. We can do extra condition checks. Okay, but we can actually probably subsume all these four into one. Okay, but it doesn't really matter now because like it's just adding one more line. It's not that bad a deal. Okay, just for future note for my own reference, we could actually subsume the up, down, left, right into one. Okay, so over here, this is the distance. Okay, so there's a few things that we need to do now. Now we could take the total distance plus the heuristic distance over here, and we could update the heuristic distance here as well. Yeah. Then we could potentially in this queue here, we need to take out the we need to take out the first node here with the highest priority, right? So this could probably be done with a sort of heap. Yeah, let's just do a heap for this. Okay, so C# priority queue. I wonder if priority queue, um, this priority queue definition will work for okay, let me just search that because it would be so much easier if we could use a priority queue plus work with Unity. Yeah, so we have an element and a priority, and then it should arrange by itself when we insert the element in. So when we insert in, it does sort of a heap search to place the element in the right position. So it's like doing a divide and conquer. It's search in the middle, then search in the left or right based on where it is. So when we add the element in, we just need log n number of times um, to do the insertion. So it's O log n time, O n log n actually, yeah, because of the n elements here. So we could use priority queue. Yeah, O log n. Yeah, sorry, the insert is O log n. By repeating n times, so it's n log n overall. Yeah, looks like we need to do like our own kind of heaps. This is the priority queue that we want. Okay. Yeah, I guess I'll just take his code here. Yeah, like custom priority queue. Okay, and then we have item and a priority. So when we enqueue the item plus the priority. Private where the item does not need to be item. So there's a class called priority queue item, which when you enqueue and dequeue your queues. Oh wait, no. This is also based on priority queue. Yeah, which may not work in C sharp. So let's see. I mean, I have an easy way that I can think of doing this. Yeah. Oh, this looks good actually. Return lowest Actually, let's just copy and paste this. We'll edit this later. So I like how he did it. So he implemented a priority queue class himself. So that will do. So maybe what we'll do is we'll create a new script called priority queue. Okay, maybe we just call it PQ to avoid any conflicts with the Unity priority queue. So we could have like that, and then we'll just copy and paste this code here. Yeah, so we are creating our own priority queue. So let's copy and paste here. And this priority queue doesn't need a mono behavior. So just like that. So he used a tuple, this tuple. So yeah, I kind of like this. So systems collections dot generic. What is using API? Node requires API games tuple implementation for Unity 3D. Also, I need to download this tuple thing as well. I don't think we have an inbuilt tuple class in C Sharp. So this is so frustrating, because if we were to use Python or what, so easy. There's a priority queue framework, but C Sharp, I don't think we could use priority queue directly. Actually, the tuple is a framework, right? So we don't really need to really that might be outdated. So this tuple should be already there. Like tuple T class was already introduced in .NET 4.0, which is good enough for our use case. So okay, we have a tuple of type and double. Okay, okay. So count returns the number of elements in the queue. That's fine. Yeah, we could do a dot count. Okay, like how it's normally implemented. Okay, which will return this inner tuple here. Okay, and then when we enqueue the item, okay, void enqueue the item and the priority value, we create a tuple. Okay, so I wonder if tuple dot create is tuple dot create is a C sharp thing already. So we could use this tuple dot create item and priority value. So two things. So this is the item type and the item type here is actually an integer. Okay, so that will be needed. Okay, so after that, return lowest priority queue and remove item from queue. Yeah, pick, we don't need this. Just when we dequeue, we just take away the item. So best priority index 0, I 0 elements dot count. If elements I dot item 2 smaller than elements best priority index dot item 2. Oh, that's a bummer. Yeah, he didn't implement this with a heap. He implemented just a for loop to search through the elements, which means that it will take pretty long. Um, it will take on time to find the best priority index. And if we really were to do this, I don't really need this class at all. Yeah, I wanted a priority queue with a heap implementation. Okay, why not? Let's just do the priority queue from scratch ourselves. So we use a heap in C sharp. So let's see, heap in .NET. I'm pretty sure there's a heap function in C++. Is a very simple thing to do a heap. Yeah, let's see whether C sharp has something has a heap that we can implement. So let's see. Oh, this doesn't tell me anything about heap. Okay, there we go. There we go. I'm just a bit reluctant to do the heap because like there's a lot of code to be done. Comes 2 plus 1. It'd be good if we could just use a pre-built min heap. Yeah, that was the problem with C sharp priority queue. I mean, I could use an ON time to search to search the list of elements. Like over here, this DQ just search through all the elements that we store in there, and then we just find the item with the minimum priority index, which is okay, but it just means that once we enqueue the item, okay, we didn't really add it into a heap or anything. Yeah, we added to a list. If we added this to a heap, it'll be O log n insertion time, but then the extraction time when we take it out of the heap will be O1 because we can just take the top element from the heap. It will definitely be the minimum element if we do a min heap. Yeah, so yeah, it would be good if we could do a heap implementation of hard priority queues. That's an important thing that we want to do. So I want to do a binary heap. Yes, that's what I want to do. I wonder if there's I wonder if this priority queue, kind of works. The priority queue class is generic. Looks like what we have already. We want a count method. This kinds of like teach you how to. Okay, let's see whether we could use the default implementation of priority queue inside. Yeah, so something like this, priority queue. Okay, and then priority bank. Okay, okay, let's just search the .NET 6 version of priority queue and see whether it works. .NET 6. I knew it was going to be a pain, I can tell you this. Because C Sharp doesn't have this inbuilt. Nope, doesn't work. A new priority queue in .NET. Yeah. They didn't really say the priority. There we go. Priority queue string in, enqueue, 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 number.eq. Okay, let's just see whether we could just add a priority queue over here. So instead of doing a queue, let's do priority queue instead in the breakfast search. So priority queue equals to new priority queue. Okay, if this doesn't work, then I'll use my own function pq priority queue. This one will be integer float. Okay, the priority will be the float. Okay, so when we enqueue it, we enqueue the node, okay, plus the distance up node, like that. Yeah, let's just put all of them here. You know what? Let me just try doing the priority queue just to make sure that kind of works first. So let's just do the distance to the node itself without calling the. Oh, I noticed an error here. This one should be left node, left, down, right. Okay, let's just call the priority queue this. Then when we dequeue it, it will be here. Node.dequeue, you get the current node, just like here. Okay, so let's see whether this code kind of works first. Let's see. The tag or namespace priority queue could not be found. Okay, so see. It means that there's no priority queue in here. You know what? Let's just use we just use our own data format. We use this PQ. Okay, let's create our own priority queue. Later, I'll just try to create a heap if possible. Because this thing here, to do use heap to implement this. Yeah, I wonder if there's an inbuilt heap in C sharp. But as of now, this probably would do. So PQ DQ is to return the best item, and Q is to enqueue both together like that. So we could do a PQ here. Where was I? Yeah, yeah. So PQ and PQ. Tuple could not be found. Are you serious? There's no tuple in C sharp. I guess we could use pair also. Yeah. I wonder if there's pair in C sharp. Tuple string in. Uh, I guess I'll create my own tuple class. I guess. Yeah. What a bummer. Yeah. So many things cannot be used. I'll create my own tuple class. Create my own tuple class. Tuple tu. Okay, and then here will be public tuple. Okay, and then this one public tuple. This is the initialization method. If we don't have anything, then we have like that. So here's item one, item two. We could do the same here. So item two, item one. Yeah. Item one, item two, item one, item two. Yeah. Since we call item one and item two here, we could do this class for tuple. So with class types T and class types U. And then when we initialize the tuple is with we initialize with T first and U second, like that. T and double, which will then get set to the first item and second item. And then when we call the function item one, it is a get and set function, which means we can access this element item one like that. And we can also set the dot item one to be like something. So basically, this get and set is basically saying that we can do like dot item one, dot item two to like basically like this. You can access, you can read and write. Yeah, the tuple. So I created my own custom tuple class, and this will be the priority queue class. Let's see what are the errors. End of file expected. Line 18. Did I miss out? I have one extra. Yeah, I have one extra. This. I don't think I need this colon at the back here. I think this would do already. Using generic type tuple requires two type arguments. Okay, so priority queue here just initializes with a type here. So maybe I could do double two types like that, T and U. So then this will be given in here. So the priority value, we don't fix it as double. We can just fix it as a type U, okay, which will then be able to be configured uh, in the other script here as well. Using the generic type tuple TU requires two type arguments. Then I give, so in the enemy movement PQ, in float, I gave two elements already. So in comma float. Okay. Uh, this looks alright actually. C cannot implicitly convert type in float to int. I think it's because of this PQ here. Operator cannot be applied to operands of type U and U. Okay, so let's see. C sharp generic types. Yeah, so T represents a generic class here. Okay, but what if we want to do like, maybe I need to do T comma T instead of T comma U. Multiple generic types. Yeah, so this is a little advanced here today that we're doing with C sharp. We are trying to like sort of create our own classes because C sharp unfortunately doesn't have a priority queue. Yeah, so how do you do with two types? So T1, T2. No, I don't need this constraints. I'm just thinking of doing T comma V. This is new to me. This is new. So I guess I could do a where. I'm thinking that I could just, instead of T comma U, I could just do TT. No, but maybe TV. Not sure, but Oh wow. Yeah, the example was right. But let me just search T and V in C sharp generics. There we go. There we go. KVU. So U is system. Okay, let's see. T is a class type. U is a system type. What does V mean? V. They didn't really explain what is V in this. So what is V here? T is a class type that I understand. Introduction to generic. So T is class types. Type parameter T. Okay, let's just search generic type V in C sharp. Oh, there we go. Generics in C. Oh no, this is C++. I know T is generic type, but V is wow, TV, ETP. Wow. Okay, this is quite advanced. Even I have no idea what this is doing. But I guess V stands for value. Key value. I guess V stands for value. If X, Y also works. Wow. Yeah, I guess it's just a name. I mean, you could just name it anything. But TV, if it works, then we're just gonna use it since it works. So PQ number 40. Mm, I mean, I don't know. Wonder if this changes anything. Cannot be applied to operands of type U. T2 maybe? I don't know. T2. This is proving to be more of a headache than I thought it would be. Operator cannot be applied to. Mm, just now TV didn't work, right? Because at one point of time, TV kind of like got no errors at all. Okay, let's search for this error and try to debug it. Yeah, debugging. Operator cannot be applied to types T and T. Yeah, let's just take a look what this means. Okay, does not support operators or rather operator constraints on generic type parameters on this point. Oh, no wonder they say that must be I comparable in order to do the comparison. Okay, so it looks like we need to specify. Okay, so the issue comes about over here when we compare the item with respects to this item here. So it means that in the item 2 itself, because we do not specify the type, so when we compare it like that, we do not have a way to compare these two operations. Okay, error, there's no argument that corresponds to the priority value of int float 305 918. Yeah, so over here, initial node priority will be like 0. Okay, that settled some stuff. Cannot convert PQ in float to int 36238. Actually, come to think of it, the distance is an integer also, right? So actually, this one could just be int to save the trouble. 352 node.enq int. This distance down node is an int also, right? This distance down node is an int. Let's just do a priority queue with both of them the same. Yeah, I'll make my priority value the same as the item, right? It's probably not for the best, but in fact, my tuple can be just tuple t. Yeah, because everything will be just given one value. Tuple t, and everything will just be t. So my first and second item will be of the same value. Using generic type tuple t requires one type argument 97. Like that. Let's see how they did this pair. New pair. Oh, type expected. I remember sometimes this bracket might cause problems. Let's just see. Operator smaller cannot be applied to. Oh, they treat this as greater than. Okay, so this is not the issue. Such an annoying thing that we can't get this tuple to work. Yeah, it's really very simple, I guess. Using generic type tuple T requires one type argument. 25. Oh, because I used tuple.create. Okay, method must have a return type tuple 10. Void. This doesn't return anything. PQ line 25. Oh, wait. This is done using this tuple.create, which will return the tuple. So we need to return the tuple. So yeah, return this. How's that? New pair. Tuple. Tuple T tuple equals to new tuple. TT item priority red. I think this is the reason why why it failed. Actually, if I could just use this thing new tuple here rather than tuple.create, I think this would work already. Okay, so this is just tuple T. So public tuple like that. Yeah. This new add in the tuple itself. Ah, PQ line 40. Smaller cannot be implemented on this. Maybe we just fix the second item as ints. Then we can always implement the comparable. cannot convert from t to int. 25. Let me go and read up more on this generic type elements. It's quite useful, but now I'm just constraining the use of it because I didn't use a generic variable. Okay, 289 line 13, line 289, which is here PQ. Because now PQ only takes in one. Yeah. I think I think I can do for two actually, but you know what? Let's just save the trouble. We just assume that the priority will always be an integer, right? We just assume there's always an integer for the priority. Yeah, we just do a PQ with an integer as the item itself. So we only store the item. The priority we assume it to always be an integer because it kind of works with this right now. See the integer priority value. Then when we do a comparison of the integer, we don't have to create I comparable to do this. I think this is simple enough. Let's just hope that it works. Okay, 332 error cannot convert PQ into ints. 33236 cannot convert. 33236 is here. Distance node. Oh, yeah, this should be, instead of node, this should be current node. Yeah, let's just get the basic A star search working first. I'll probably need to do some homework to figure out how to use generic types because we had to implement all this, which is something I never did before. But this is probably how people implemented library class functions. So it's quite interesting to learn how to do this. Yeah, now I cheated a bit. My priority value for the priority queue, I use an integer. And I haven't implemented the heap yet. So wow, already this has caused so much trouble to do it. Oh yes. Okay, so now I just implemented this thing without the heuristic function. So it only adds in the priority queue with respect to the distance itself. So the priority queue, what it will do is it will take the priority value, okay, and then you'll find the minimum value, okay, in order to select the element with the smallest value in order to dequeue it, okay. So right now, I'm just doing this without the without the heuristic. So let's see whether it works. The PQ whether it works. Okay. Okay, looks good. Looks good. Looks like it's working. Oops, it died. Okay, let's try again. Oops. Guess I can't go there. Is it that hard to not die? Oh, there's something wrong with this. It's stuck. Okay, that was weird. Why did it get stuck? Let's try again. Looks like it's working though. Okay, let's just try for this. Okay, so that one hippo is moving to me. Okay, and if we go here, okay, it looks like the priority queue thing is working so far. Okay, so now let's add in the heuristic. Oh gosh, this PQ, even without the heap, has already managed to agonize me so much. Yeah, so uh, yeah, I just created my own custom priority queue function, but this one doesn't use a heap. Okay, so this is not very efficient. Okay, the heap method to implement this, probably, I might do it later. Yeah, we see how it goes first. But now, right now, we want to implement the heuristic distance, which is the Manhattan distance between the x1, x2, y1, y2. Okay, so how do we get the Manhattan distance then to the goal? So these are the up, down, right, left, right. So we could create a new one, new uh, heuristic up. Let's just call it up heuristic, down heuristic, up, down, right. Okay, let's just create this, and then we need to do the Manhattan distance, which is this x1 minus x2 plus y1 minus y2. So it's just the current x, okay, minus the goal x. So what is the goal x and goal y? So that will be like the given by the end node. Yeah, actually, let's not do this because we know that we know what's the current node, right? The heuristic for the next node will be given by maybe this heuristic up node, end node, up node, and end node. Yeah, let's just add a heuristic manually to each of them. Okay, which we will then code another function to do. So this will be the heuristic to tell us how far away are we from the player itself. So this is the heuristic. Here will be up, this one will be right node, this one will be left node, down node, and the last one will be left node. Okay, so let's not call this heuristic. So estimated distance. Let's just call it estimated distance. Okay, great. How do we tell the estimated this? So let's create a new function called estimated this. So this is breakfast search, which we will label to relabel to a star soon. So void estimated this initial start node and initial end node. Okay, we just call this like that. So integer start x. So we can do something like this. Equals to start node percent x max plus 1, and then the other one will be start y equals to, so this one will just convert the node into its respective x and y coordinates, and since x max is global, so that can be done. Integer start x, and then over here we have n x and n y. Okay, so actually this is not void, this is integer. Okay, because uh, we want to return the integer itself. Okay, so what do we need to do next? Okay, we need to do an absolute function. So let's see, math.apps. So mathf.absolute returns the absolute value of a float, or it can also return an integer. So you just need to return mathf dot absolute start x minus nx plus mathf dot absolute start y minus ny. So this will be because we use the Manhattan distance. So it's like, for example, if the rhino is here, the hippo is here, we take the x position, the difference in x is between the player and the hippo. This will be x, and y between the hippo and the player and the y. And then you take these two distance up. It's a proxy to how close that hippo is to the player or to the flower. Okay, so this is a Manhattan distance used because Manhattan taxi drivers sort of estimate the distance like that. The Manhattan city is a grid like city. Okay, so 375 error. Some colon expected. 375. Did I miss out something? That's why this happened. So this under private void fix update. Okay, which means that I need to move this function outside. Let's just let's just move it up outside of the fix update. So this is breakfast search. Oh, I declared my breakfast search inside fix update. Cannot be. Breakfast search. Yeah, apparently I did create this inside fix update, which shouldn't be the case. Yeah, let's just bring it out of fix update. Manhattan distance and breakfast search. So let's keep the private void fix update separate from the rest. Yeah, this should work. I apologize for it being such a confusing tutorial because of this priority queue wasn't inbuilt. And in fact, we're not done. We still have to do a min heap here. Okay, the tuple wasn't even built in, so that was kind of a bummer. Yeah. Oh. Okay, so definitely this part of the cube here, this part of the code here is not working. Okay, so let's see. We have one close bracket, two close brackets, three close brackets. Yeah, seems to be okay. This one over here. Okay, let's just delete away this thing here first and see whether there's errors. Estimated this does not okay, so it means that the estimated this here is okay. And then when we put estimated this inside, there's a I think I have an extra bracket. Oh, yes! Oh my gosh, this was so intense. Yeah, okay, so I created a Manhattan distance, and then in the priority queue, we add in the distance to that current node itself, plus the estimated distance. And then we put into the queue. Okay, so that's good, I guess. Okay, now let's see whether it works. Okay, we collect one. Okay, only one should chase you right now. Okay, it works. Okay, and then now only one should chase, the nearest one should chase, and it looks to be working. Then finally we have everyone chasing me. Okay, very good. It's working. Ah. Oh, 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 oh. I died. Okay, so it looks to be everything's working. This two, one, two, three, four, all are working. Okay, yeah. So yeah, I'm just curious, like whether I could do like two different, like rather than doing an integer, whether I could do an I comparable to do this I comparable C sharp. Yeah, if I were to do an I comparable, then probably I could do a generic type like here. We could do an I comparable, implement the generic compare to with the temperature. Yeah, I guess this all could be done. Okay, but I mean, I'm just intending to just use a fixed priority, which is an integer here. Yeah, I know. Don't really not want to implement the comparative function here. So this enqueues with a tuple. Over here, we need to. So we could have a heap to store this structure. Okay, but I think maybe if I were to do heaps, it'll be another video. It's been quite long already. Okay, and yeah, I'd like to just end here today. And yeah, that's all for A star search. A recap of what we did: we implemented a tuple class, which takes in two objects and then just relates them together. Okay, and then we have a priority queue, which is implemented based on tuples. Actually, we can also use probably list over here also. But yeah, we implemented based on tuples. And then over here, when we enqueue it with a priority value, when we dequeue it, we select the element with the lowest priority value in order to take it out. So for the enemy movement over here, we have extra distance that to current node. So at the start, the distance is 0. For every time we run this algorithm, the distance will be increased by 1. Okay, and we are okay to do this because as long as the is visited is not there, because all the distances are nodes are distance 1 apart, we don't have to check whether the current node distance plus the travel distance is it smaller than the next node's distance. Then we update it. We don't have to do that because it is assured to be always smaller. Okay, because of the way this is structured. Okay, by right, the distance here should be all infinity, but it doesn't really matter here because we only update the distance once we can access it. And so then when we enqueue the nodes, we take the current distance to this node, which is the fx. Okay, and then we plus this gx here, which is the heuristic distance to the endpoint. So A star search takes in the distance to the current node, which is the current disk we have in the disk array here, plus the distance to the goal node, which is the estimated disk over here. And the distance to the goal node here, we use the Manhattan distance, which is just the absolute difference in the x and y axis, okay, in order to get the estimated distance. Then when we do this search, so it's actually very similar to breadth search. It's just that we don't use, we basically don't just take the first element of the array of the list or the queue. We actually pop out the element based on the priority queue. So when we do a node.dequeue here, in the priority queue, it just takes in the element with the shortest estimated total path plus the current path to the goal. So this sorts of prioritizes the most likely nodes that will reach the endpoint. So that's a star search. So maybe we should just rename this A star because we have used A star search already in this video. So let me just find my BFS and then just rename it A star. And then we test it out again to just make sure it works, and then we can end here today. And then later, if there's time, I'll do a heap implementation as well. Whoa, 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 whoa. Okay, yep, the nearest one is coming. Yeah, it's working. And then lastly, we have the last mandrake root, which everyone should come and attack you. Awesome. Yeah, that was fun. And okay, with that, thanks for watching and see ya.